Hi, welcome to the first video of Adventurous Coder, where we'll talk about tech and everything else. Well, this is my first video and my first channel as well. So, what we're gonna do today is do lead code questions, where I'll explain the brute force solution, also what additional topics that we need to be aware of and study before we solve the problem more optimal to and get a optimal solution as well. Now I'm not good with video editing as well. These are my first videos I've do. So any and all constructive feedback is accepted and I'll try to work on them in my future videos as well. Lead code is not just my aim. We'll be doing more about software engineering where we'll see what does it mean to be a software engineer. It's just not how to code, but more to it. But we'll get to that in later videos. For now, today we'll start with the most common question that's out there is with two sum. First, let's go to the question. Given an array of integers sum and an integer target, return indices of two numbers such that they add up to the target. Okay, so it's quite simple. We have say some n numbers and we have to find two numbers whose sum addition is equivalent to the target value. You may assume that each input would have exactly one solution, and you may not use the same element twice. Okay, you can return the answer in any order. Got it. So uh, now we know that there's only one solution. That means there's only one pair of integers present in this array of numbers that would be whose sum would be equal to the target itself. So we know for this, let's just quickly do something in our VS Code. Let's write something down. So let's say these are our numbers and our target is 6. Okay, 6 is will not be allowed because there are two pairs. Target is 8. The same numbers do repeat. Okay, but actually, let's do this. Yeah, this would be a better example. The target is 6. Now the possible pairs are 1 comma 5 or 3 comma 3. Yeah, because these both add to 6. But this is a wrong pair because the condition is we cannot use the same element twice. 3 cannot be used twice. But let's say if we had another 3, we can use it. So in this solution, we have 1, 5 as the only pair because 1, 2 is 3, 1, 5 is 6, 1, 3 is 4, and 1, 2 is again 3. So that's our, we have understood our conditions and we have our right answer here. Let's go through a brute force solution. First approach that we can think of is how we'll just approach it how our head thinks. Okay, how what we do is we usually add the number and see if it matches the target. Yes, that is we take a number a as 1. Now we go through rest of the array to find that b, who is target minus a. In this case, do we have a 5 or not? Yes. So we are initially here. This is our a. Okay, this is our a. Now then we go check. Is this 5? No. Is this 5? Yes. Is this 5? Is this 5? Yes. So that means we have got a pair. Let's say we had to search for 3. We go here. We see this has 5. No. 3. Yes. And then we return from here. So given this situation, let's look at how we'll write this brute force solution. So let's start with int I equal to 0, I less than number size I plus plus. Okay, now then what we are going to do next is int j equal to I, j equal to I plus 1, j less than nums dot size j plus plus. So what we are doing here essentially is getting our a value, and here we are trying to find our b. Let me just zoom in a bit. Yeah. So if nums of I plus nums of j is equal to our target, we return a pair. Yeah. Let me we call this, that will be uh, I comma I comma j. Yeah. Now else we're just gonna let it continue. Now why we have a return statement here is because we know there's exactly one pair. So let's try to run this code and see if there are any errors. Where did the run button go? Line. Did I miss a brace somewhere? Oh, okay. It's now. What if usually we wouldn't have uh anything, like we would always have a answer that is here, but as well how programming says is the function needs to be returned, and a compiler is gonna think that, oh, this user has not given us a value or any vector that they can return. Yes, so we're just gonna return them an empty array, though it should never reach this part of the code. So we see here we have got our value 0 and 1. But now let's come to the next part of the problem, which I initially skipped. That's the constraints. Now, what is a constraint and why are these important? These constraints tell us that what kind of data should we expect that our code is going to run through. So the first constraint is 2, nums of length is 2 and less than equal to 10 power 4. So 10 power 4 is 100,000, 10,000. So that means the number of elements that we can get, or the size of the array, can be anywhere between 2 numbers and 10,000 numbers. Yeah, that's a lot of numbers. And each value of that number can be anywhere between minus 10 power 9 to positive 10 power 9. Thankfully, the new C++ integer can handle this, so we are fine there. And the target value can also be the same. Yeah. Now, so this is our constraint. Now let's look at it. Let's try to figure out the time complexity for this solution. We know, for those who do not know what time complexity is, it is the amount of time taken to execute all operations in the code. So each thing is an operation. So each iteration, each I plus plus, or let's say each line in simple is an operation. So if you look at this code, this for int I equal to 0, I less than nums of I can run anywhere between 1 to nums dot size times. Yes, same goes for j. It will run for any time, for every I. It will run I plus 1 2. nums.size minus I plus 1 to nums.size times. This if condition will run only once in every j. So this is only going to run once in it, and same goes for this, once. So now for a time complexity of a for loop, we would determine it like the so before we calculate, we always consider the time complexity with the worst possible outcome. So if I tell you that a for loop can run anywhere between 1 to nums of size minus times, I'm going to assume that it's going to run the nums, like the entire length of nums instead of just one, because I want to consider the worst possible situation that I have to do and see how long will that take. So your nums dot size is going to be n. Okay, and for j, we for every I. So let's say if the initial I is 0, it's going to run n times. But when I is 1, it's going to run n minus 1 times. For I is 2, n minus 2 times. Yeah, but we know that for the worst possible outcome, it's still going to run n times. Yes. So we are just going to multiply that by n. And the next one is the if condition, which is 1, and the last is 1. So this becomes n squared. So our time complexity for this code is n squared, right? Now, is this good enough or not? That question always pops up. Is this an optimal solution or not? Or is this a feasible solution that when I click submit, it will be accepted? Now, how do we know that if this is or not? We take the values that are present. So if we take our n to be 10 power 4, that is 10,000 times, that's going to be 10,000 times square. So 10 power 4 becomes 10 power 8. That means it's going to do 10 power 8 operations in the worst possible situation. Given that scenario, we can't just simply say, oh, it seems a lot of numbers to us. 10 power 8 is a very big number. But for a computer, that might not seem such a huge number because that the number of operations that they do in every second is again a lot. So a lot of those factors go into determining if the computer will be fast enough to perform these many operations or not. And many more factors like the compiler and this type of system that you use, everything else. But let's not go into that right now. For now, for the case of this question, I can confidently say that 10 power 8 is a decent number of operations that this code can do. And it's not huge. And let's try to submit this code. So it got accepted. So this works. And we see that it ran in 54 milliseconds. Yes. But, oh yeah, I have done this before. But yes, I'm just showing it once again. Uh, Now, this question has also one more follow. Can we do better than O of n square? That is n power 2. Ideally, yes. Though we know that the sub got submitted, but we are not just developing for you know getting an answer, but we want to get in the fastest possible manner or in the most optimal manner to ensure uh, we write more efficient and effective code. We do not want to abuse our computer systems. Yeah. So let's try to solve this in a more optimal manner. Now, before we think of an optimal solution, or rather, I say what the optimal solution is, I would like you to pause here and think of a solution yourself before you come up. Try to not think of a coding solution, but think of what is required before we can move forward and find that coding solution. What is the next possible human tendency to do or human operation to be performed when we are trying to solve this kind of problem? You can pause the video, but I'm just going to continue with my solution. Let's go back to our VS Code. Now, let's say I'm at, we have this 1.5, yes. So let's see how we as humans try to solve this problem. Another more manual. I read through the array only once. So let's say I read 1. So I know that 1 exists in the array. Then I go see 2. Okay, now 2 also exists in the array. Oh, then or rather, let me go back. I see 1. Okay, target is 6, so that means I need to see 5. Have I seen 5 yet? No, I have not. But okay, I'll move forward. But I know now that 1 exists in the array. I see 2. Now 6 minus 2 is 4. I have not seen 4 yet, but now I know that 2 also exists in the array. Then I go see 5. 6 minus 5 is 1. And I know that 1 exists. So that means this is the pair that this is one solution that exists and I can return it. So I just need to go look up where 1 is and then return the answer. That would be 0. That would be 0 comma 2. Yeah. So that this is the kind of operations that our brain performs when we try to solve this problem in person as human. Now we can't do it for 10 power 4 numbers, but we can do for a smaller array and see how are we solving it so that we can write a code for it. Yeah, this helps us to see what is needed. Now we know this is how done. Now we made our brain remember these values. That okay, 1 exists, 2 exists, go look back. But how do we make code remember this? For that, we need to learn a topic called as hashing. So let's go read about that. So hashing is a very common data structure that is used. Now coming to why I am bringing this into picture, because way I have seen is how it is effective to use Leetcode is not just to solve the problems, but also read, learn. You can't always come up with solutions on your own. You need to learn topics to be able to solve the problems better. So continuous learning will help you solve those questions better. So that's how I'm going to introduce new topics to you over the course of time. So today I'm introducing to you hashing. I should have introduced array as well, but I'm assuming you know the basics. So hashing is a very commonly used data structures that is used to retrieve information in an unordered manner. And what does it mean is, let's say if I've given an array. In this array, I know for that index 1 value is 2. Yeah, because I know the location of it. Correct. But let's say if I ask you for the value 1, what is the index? Can an array return it? Yeah, but you'll have to go through the entire array, which is very time consuming, and that's not an optimal solution. So what hashing does is it has a formula the, to store the numbers in a different manner. So it's or the not numbers but values in a different location. It can store in various different locations, but every time you tell that okay, I want to know where is value 11. It just return me the value. It'll return me whatever corresponding value is. Yeah. So hashing as a data structure is commonly used, and one of the normal ones, or it's uh, it's called as hash table or a hash map. You would have heard about hash map as well. So these are used to pick up values that are relevant to the keys. Now let's see how we can use that in the code. What I'm going to do here is I'm going to add a map of here, which is a hash map of int comma int. That means my key is int and the value is also an integer, and call it m. Okay, let me just comment out this code. Now for every key, let's bring this. I think we can close this, or let me just For some reason it's not going down, but okay. We have an M. Now what we're going to do is we're still going to loop through the nums array. Nums size I plus plus. Okay. Now what first thing we are going to do is calculate our value that we need. That is target minus nums of I. If you remember, that's what we did while trying to solve the problem as a brain as well. We first saw, okay, what value do we want to look for? Then what we do is find for it. So what you might want to do is read about maps in C++. So this is a very common thing that we as engineers do. Google is our best friend. But what you need to learn is how to read your documentations, how to search for the right places. So here I'm using map in C++ language. So I'm just going to quickly search map in C++. I agree, and there's going to be a lot of documentation. And I agree that documentation sometimes are huge, but you need to be the more you read to it, the more you get used to understanding how to read documentation and looking for the solutions in the right places. Now I know that I want to do a find, correct? Here, uh, well, so let's see. I have a map. Now, how do I get a value out of it? Let's look at that. Mm, find. So I can see that they have an array that they have a find function as well. I'm not sure why they haven't. Oh, so they have it here. Usually it's called find or search. It could be one of them. So we have a find function. It's a built-in function, or the key is not present in the map container. It returns an iterator to the constant iterator. So map.end. Okay, if the key is not present, that means it'll return the value same as map.end. And if the key is present, it's just going to return an iterator. Cool. Mm. But we are not bothered about what it returns if it's present, but rather we are bothered about what it returns if it's not present. So let's say if I find, now I go look for the value. Now if it is not equal to m.end, that means this value is present in the map. That means I have already looked into this, I've already recorded this value. So here I can safely return vector int of, oh yeah, now comes the funny part. The first one has to be something, I'll just leave. And this is I. So this is the second location. Now we don't have to return the value, but the location of the value. So here I'm just gonna do m.find of value. Okay. Now, but what do I store in it? What am I storing? So let's say if it does not exist, I'm gonna do an insert just to ensure you guys are used to this documentation reading. We remember seeing pair insert here. What we do is we do an insert with this kind of a syntax. So I'm just going to insert the nums of I, that is the number that I just visited. That means one exists and it exists as location I. So when I do this, so let's do a dry run of the code. Initially, nums is equal to, what was the example? 2, 7, 11, 15. 2, 7, 11, 15, and initially m is empty. First I is equal to 0, value becomes 6 minus nums of 0, which is value equal to 6 minus 2, making it 4. Yeah, so we have value as 4. We are gonna do m dot find 4. Initially that is empty, so we get n. We don't go inside this if condition, and now we insert in the end. So let's just go up and update it. So we updated 2 as 0th location. Next, we have our I as 1, nums of, let's just make it I so that I don't have to write it every single time. That makes it 7, which is minus 1. Now, do I find minus 1? No, I don't. So I'm just going to go insert nums of I, which in this case is 7 of at index 1. I, oh, my bad. The target is 9. 9, 9. So this becomes 2. So m dot find is 2. So I do see that m, let me go back. So I do see that m exists. 2 exists. I know. So here I'm just going to return 0, which is the corresponding value of 2 in the map, and I, which is the value 1. So let's just quickly run this code and see how does it perform. Okay, ouch, I have done some mistake here. Yeah, so this we have to access. So it's an iterator, so we have to access the second value of it, which is a key value pair. I fixed that code, it is correct, and now we submit it. And let's see how does it perform. So last time we had 54 in milliseconds, but now we have a 7 millisecond runtime. So we have reduced it by close to 47 milliseconds, which is a huge change. If you do in percentage wise, we have reduced down the time by 85 to 90%. So that's how we use a hash table to optimize a solution. Now, as for how long does this take? This we are passing through it only once. So the entire array is being passed once. So that is n times. That is nums of size n. Now for hashing, I've skipped that part. You can read on your own. But the time it takes to find a value is O of 1. That means it takes just exactly 1 second because it's like indexing. So in an array, if I tell the find me the second index, it does not, I don't have to traverse to the array. I can just go pick it up. Yes, I know where to look. So it takes an instantaneous time. That means it takes only 1 second. So, and there is no loop inside it. So the time complexity with hashing becomes O of n, making it like much faster than the previous approach where it was n square. 10 power 8 operation versus 10 power 4 operations for the worst possible scenario. So yeah, this is how we'd solve a two sum in the most optimal manner. For any questions, you can drop it in the comment. I'll answer them, and any feedback is also much appreciated. Please drop it in comment as well. I will try to upload as frequently as possible and uh, solutions as well. Though with my job, I'm not sure, but yeah. Thanks for watching, and look forward to the next episode or the next video.